Hey, how you doing, everybody? This is Mr. Beckstrom again, and today we're going to be going over Chapter 1, Section 4. This is on percent problems, and we're going to be looking at a form that we're going to use often throughout the rest of the semester, so it's a real good idea if you spend maybe a little extra time on this section and make sure that you understand all the examples, go through the book, make sure you're understanding the homework in my math lab. All right, so let's get started. So with percent problems, we can often use this form here to go ahead and solve. We have three different variables. The one right here on the top of the first ratio is P, which stands for part. It's usually the part of some whole. The B stands for base, or you can look at that as the whole amount. The R stands for rate, which is also often the percentage, and we'll often look for a percentage sign in order to identify our R. And 100 is always going to be 100, so we never have to solve for that. We just put 100 on the bottom in the denominator of the second ratio. All right, so we have a couple of words that help us identify which quantity belongs to which variable. Um, the B is often associated with of. So if you see something that says like of 75 or of 200, that quantity or number is going to go on the denominator of the first ratio. The top of the first ratio, the numerator, is P, and it's often associated with the word is. So if I saw something that says is 7 or is 13.5, that number will usually go on the top of the first ratio here. And the R is associated with the percent, so I'm looking either for the word percent with that quantity, or I'm looking for a percent sign. If I see either of those, that's going to go here where it says R. And then I just cross multiply, divide, and solve. And we'll be looking at a few examples, including a longer word example at the end. All right, so the first example. What is 75% of 200? So go ahead and identify the P, the B, the R, set up the proportion, and solve for the missing quantity. Remember, you should only have one missing quantity in these problems. So go ahead and pause it. All right, so here's the solution. So we have the question, what is 75% of 200? Well, the 75 has the percent sign, so that's pretty easy. So we replace the R with 75, as we did down here. The word of, it says of 200, so we said that 200, since it's associated with of, goes on the bottom of the first ratio where the B is. So I'm going to replace B with 200. And then that only leaves the P left, and it says what is. So that what, which is the unknown, is what we're trying to solve for. So I'm just going to leave the P there. And that's what we're going to solve for. So we cross multiply. 100 times P is equal to 75 times 200, which is 15,000. Divide both sides by 100, and I get P is equal to 150. So I could kind of replace that up here where it says what, and say 150 is 75% of 200. And does that make sense? Make sure you ask yourself if that makes sense. Is 150 about 3/4 of 200? And hopefully you should think that does, because it is. All right, so going to the next example. What percent of 50 is 40? So once again, identify the three variables, set up and solve the proportion. Go ahead and pause. All right. So go ahead to solve this. It says what percent, so right away we should know that we're looking for the percent. So we're going to keep the R there because we don't know what it is. It says of 50, so we said that goes where the B goes, the base. So we're going to replace that B with 50. And is 40. Is associated with the part on the numerator of the first ratio. So we're going to replace the P with 40. We cross multiply. 50 times R is equal to 40 times 100, which is 4,000. Divide both sides by 50 to get the R by itself. And the rate or percent is equal to 80. So 80% of 50 is 40. All right. Sample 3. Find such a number such that 25% of it is 17. So once again, we kind of have a word problem here, and this one seems a little bit trickier than the last two. But if we just kind of take our time, identify our variables, and plug them in, we should do fine. So go ahead and identify your variables, set up and solve the proportion, and when you're ready, we'll press pause, and we'll go to the solution. All right, so find a number such that 25% of it is 17. Well, the 25 is obviously our percent, so we're going to replace the R with 25. And it says is 17, so we know that is associated with the part or the P, so we're going to replace the P with 17. That leaves us the base, which isn't quite as clear in this problem. So sometimes we have to find our missing quantity by kind of a process of elimination. We find what we know, and when we get down to the last variable, we know that's what we're going to solve for. And sometimes we're going to have to do that. Sometimes it's not going to even have those words that we're looking for, the of and the is. We're just going to have to kind of use that process to get down to what we need to find. All right, so cross multiply, 25b is equal to 17 times 100, which is 1700. Divide, and you get b is equal to 68. So 68 is 25% of 17. I think I can't say that wrong. But find such a number. So 68 is such that 25% of it is 17. I think that's a little bit better way of saying it, although it's still, I think, a little bit tricky. All right, last one we're going to work on kind of a longer word problem where we're going to have to use the fact that the B or the base is the whole amount and the P or the part is just a part of that whole. So Home Depot orders lumber that is at least 90% clear of defects. In an order containing 6,553 linear feet of lumber, what is the minimum amount of lumber needing to be free of defects? So let's just identify our three variables and set up and solve their proportion. So go ahead and pause, try this on your own, and then when you come back, we'll look at the solution here. All right, so let's start with kind of what we know here. It says 90%, so right away that 90 is with the percent, so we can replace our R with 90. The next thing is it gives us this number of 6,553. Well, we know that either has to be the part or the whole. Well, this is the entire order that they're talking about. So that should kind of clue us in that this is the whole. If they were talking about a part of that order, then that would be our P. But they're talking about the entire order here is 6,553 linear feet. So we're going to go ahead and replace our B, which is synonymous with our whole, with 6,553. That means that we are solving for our P, and we use the process of elimination there. So go ahead and cross multiply. 100p is equal to 90 times 6,553, which is 589,770. And then we are going to divide by 100. We get 5,897.7, which if we're dealing, when they're asking how many feet, we're going to round usually up to the next foot, just so we make sure that we have enough. So that would be 5,898 linear feet of lumber must be defect free. All right, well, thank you, everybody. And if you have any questions, please shoot me an email or give me a call. All my contact information is on Moodle. Thank you, and have a nice day.